Okay, so it's time. Hello, everyone. And just a quick check. The voice, is it audible? Less, more? Okay, I don't want to shout into your ears. So, yeah. Good evening, everyone, and welcome to this session. And first of all, thank you for choosing this late session over an early happy hours. I know you're waiting for your happy hour. So, I'm Avik Mukherjee. I am a senior security consultant with AWS Professional Services, and this session I'll be co-presenting with my colleague, Aditya Patel. So a bit about myself. Before I joined AWS, I was a QSA. So for folks, QSA, an external auditor who does PCI DSS assessment. So I was QSA for DSS, and I was also a point-to-point encryption QSA. So during that part of the career, so I interacted with many of the clients, and we saw that scoping and segmentation were two main interesting talking points that came up in every assessment or an advisory engagement. And that is the exact topic that we'll be discussing on, is to how to architect for proper segmentation with respect to PCI DSS on AWS. So at the end of the session, we'll try to take away three major goals. So first is we'll try to understand why segmentation and scoping is important with respect to PCI. Secondly, we'll look at what is the current guidance from the PCI Council on scoping and segmentation. And thirdly, we'll look at how to apply this guidance on AWS to build segmentation controls and to build validation for those segmentation controls. So just a quick look on PCI. So PCI security standard has developed and maintained a number of security standards that are aimed for different entities. So if you look at the PTS, the security standard aimed for manufacturers who are developing POS systems. You have the PCI DSS aimed for developers who are developing payment applications. And similarly, we have a DSS, which is a data security standard aimed for entities that are handling credit card data. And today we'll be focusing on the DSS standards. But the aim of all this standard at the end is to protect an account data. So when we say account data, what do we mean? So account data consists of two major portions. One is what we call the cardholder data, or the CHD. This is the 16-digit credit card number that you see in front of your card or sometimes at the back of your card. It also has some ancillary data like the name, the service code on it. The second part is the sensitive authentication data, which is the magnetic strip that you see at the back of your credit card, or it's the 3-digit, 4-digit CVV that is associated with it. So all the standards have one aim, is to protect the account data. We'll be using some acronyms, and just to familiarize ourselves and to clarify, one is CHD, which is the cardholder data, and what is CDE, which is the cardholder data environment. So cardholder data environment is accumulation of the people, process, and technology that interacts with credit card data directly. So just making sure we understand these acronyms as we'll be using it. So just to give a brief overview of DSS, and you may be already familiar with it, but just be patient with me just to set a level set. So it has 12 major requirements, which are categorized into 7 domains, each aimed at different aspects of security, like building a secure network, protecting your cardholder data environment, developing a vulnerability management program, or developing an information security policy, all aimed to protect the cardholder data environment. And if you look closely to these requirements, and I know it's a lot of text, but from your past experience, you'll see that scoping and segmentation is not a PCI DSS direct requirement. So why we are talking about scoping and segmentation? And so colloquially, in the industry, scoping and segmentation is referred to as requirement zero. This is because this is the first thing that you need to address when you are building your compliance program. So through scoping, you come to know what are your in-scope resources, because you need to know what you want to protect before you can protect them. So this is the stage that is known as stage zero, where you are finding out what is in your scope and how do you need to segment it out from what is not in scope. So talking about PCI Scope, it's an accumulation of people, process, and technology that interacts with CSD and or can impact the security of your cardholder data environment. Scope is defined by you as an entity who is undergoing an assessment. However, the scope is validated by your QSA if you are undergoing an external assessment or an ISA, depending on the type. The scope is validated by the assessor during the annual assessment to make sure that the scope that you have defined actually is the scope that follows the PCI DSS requirements. Anything that is considered to be in scope is required to meet all applicable PCI DSS requirements. Just to note, not all requirements, but all applicable PCI DSS requirements. So why segmentation? So we have defined our scope, but why do we need segmentation? So if you are an organization, you have your whole organization resources, maybe IT resources, people's processes, but you don't want everything to be in your scope. This is just to reduce your compliance work. So you identify the things that are in your scope, and then you can designate the things that are not in your scope to be an out-of-scope system. But this is just a theoretical process we did. We identified what is in scope, what is out of scope. We haven't done anything yet technically or from a control perspective. And DSS requires that, or the guidance is that for a system to be considered out of scope, there has to be reasonable assurance in terms of controls to prove that if those out-of-scope systems gets compromised or they have a negative security factor, they cannot impact the security of your CDE systems. And this is where we bring in our segmentation controls. So segmentation controls are those controls that ensure that your out-of-scope system is truly out of scope, and they do not have a negative impact on your CDE systems. So segmentation primarily serves two purposes. One is it reduces the security surface area for your CDE systems. You have less things to protect, and that's why the less security surface area. And as a byproduct of the reduced security surface area, what you get is your reduced scope. So your PCI DSS scope is now not your whole organization, but a subset of it. Just a quick tip here, that segmentation is one way by which you can reduce your scope. There are multiple other ways, like if you use a PCI validated point-to-point encryption solution, or suppose you have outsourced your credit card processing to a service provider. So there are multiple ways to reduce your scope, but in today's talk, we'll be focusing on segmentation and how it's done on AWS. So a quick throwback. So PCI in the year 2006 released a guidance on what they say that how your scope should look like, what are the segmentation boundaries or the controls, what are the criteria that has to be met by a segmentation controls. So in this guidance, it categorizes your systems into three primary categories. One is your CDE systems, which is your core of your scope. So CDE systems are those systems that directly interact with credit card data, so that store, process, or transmit credit card data. Second part of the CDE are those systems that do not interact with credit card data, but are in the same network segment or have unrestricted access to your CDE system. So for example, you have a web server which is receiving credit card data. This is your CDE. You have another web server on the same network segment without any firewall or any type of filtering. Even though that second web server is not receiving credit card data, but because it is in the same segment without any firewall protection or without any network filtering, that is also considered to be a CDE. So your second category of systems fall under what is known as the connected to or security impacting systems. So these are the systems that do not handle credit card data, but they have an impact on your CDE. So this can be systems that manages security of CDE, so things like an antivirus server that provides antivirus services to your CDE. This can be systems that are used to maintain a PCI DSS control also. So for example, an NTP server. An NTP server helps you meet a PCI DSS requirement, and thus an NTP server also falls under this category. The third type that falls under this category are connected to system. So for example, again, take the example of the web server that is reading credit card data. You have another application server or a reporting server that is extracting non-credit card data from this web server for reporting purposes. Now, it's not handling credit card data, it's not fulfilling any PCI requirement, but it has filtered network access to your CDE. And because of that, it falls under your connected to systems and should be considered in scope. And the third category is your outer scope system, which you can safely consider it outer scope of your PCI DSS assessment. But for that to be considered as outer scope, you must have reasonable assurance that those systems do not have any connectivity, nor do they can impact the security of your CDE. So in a nutshell, this is what the guidance provides. So now we'll look at how this guidance can be applied on AWS. And before going that, you may have a question, like many of you may have been doing PCI DSS assessment on your on-prem environment. Why it is different on AWS? So AWS has some unique characteristics that we have to keep in mind before defining our scope or our segmentation boundaries. So first of all is the AWS shared responsibility model. So as per the shared responsibility model, AWS in your PCI DSS environment is a service provider, and you are the consumer of the service. So the security is shared between AWS and you as the consumer. And hence, the compliance requirement is also shared between you as an user and AWS as a service provider. So you have to understand this differentiation for each of the service that you are using so that you can define your scope appropriately. Some other characteristics are like virtualization of the network. The AWS network is a software-defined network, so it has some difference than your physical network. AWS service are like abstracted services. They are a mix of abstraction. Different service has different abstraction layer, and you need to take care of this. AWS's services are what you call an elastic in nature. So things go up and down as you need. So the segmentation boundary or the scope you are defining has to ensure that they take care of this elasticity of the environment. And one other aspect with AWS is, as most organizations are moving to AWS, at certain period of time they would have two running environments, one on AWS and one on your on-premise. So you have to take care of this hybrid architecture and do your scoping accordingly. The next unique thing about AWS is the communication layers. So if you look at the scoping and segmentation guidance, it says that the intent of segmentation is to prevent communication in between an out-of-scope system and in-scope system. Now, communication on AWS can be at different layers. So it can be at a network layer, which is primarily for infrastructure services, and it is also at API layer or the application layer, primarily for abstracted services, and we'll look into the details of that. So while talking of this different type of services, can I have a quick raise of hand who think that currently there is 150 plus AWS services? Any? Okay. So the point is there are numerous services, and there is new services coming up every day. But if you look at it, those services can be categorized into three main categories. So one is your infrastructure services. So these are the services where you are responsible for the underlying OS, the network isolation, the logical isolation, and the security of the data on those services. So this can be like your EC2 instances, ECS or Elastic Container Services, where you have access to the underlying OS. You define isolation for those. The primary form of communication for these services is your network communication, and hence your segmentation control has to ensure that network isolation is achieved through your segmentation boundaries. The next layer of services is containerized services, and just to make sure this is not the container services, this is how we describe containerized services, is a further level up in the abstraction where you don't have access to the underlying OS, but you are responsible for rest of the security of the stack. These services can be like an Amazon Relational Database Services or an RDS, where you get to choose how you define network segmentation, and you also get to choose how you define the API communication on those services. And because of this, the segmentation control that you define needs to ensure both network isolation and data control isolation. And the third is the abstracted layer, which is the highest level of abstraction that AWS provides. So things like an S3 or a Lambda function, where you only are responsible for logical isolation and the security of the data that is being processed by those services. At this layer, there is no network communication. All the communication is over an API, and hence the segmentation control is the data control that you define through your application logic, that what data is flowing through these API layers. So with this, having an understanding of the unique characteristics of AWS, let's walk through a process where we see how we can define our scope on AWS. So first thing that we need to define our scope is to identify our cardholder data flow. We need to understand what's the flow in our environment to understand our scope. So once we have identified that, the second thing that we want to do is identify the AWS services that constitute this flow. And as we saw earlier, AWS services can be of different types, your infrastructure services or your abstracted containerized services. So we need to identify which service is what, because the scoping depends on that. So for infrastructure services, we identify the EC2 instances that are handling credit card data. So we have a list of those EC2 instances. If it is abstracted service, we identify the endpoints of those service that is handling CHD. Once this is identified, this forms your cardholder data environment or the core of your scope. So once the core is identified, we have to identify the ancillary systems in scope, namely the connected to systems. So for EC2 instance, you identify the other EC2 instance that are communicating with your CDE systems. It can also be the security impacting systems. So thing again like an EC2 that is hosting an antivirus server, or that is hosting your Active Directory, providing logical access. For abstracted services, again, there is no concept of connected to system because everything is an API communication. So here we identify the security impacting AWS services. So an example is AWS KMS, or the Key Management Service. It's a service that you can use to manage your encryption keys. That in turn protects your cardholder data environment. So with this, we have identified the core and the ancillary services, and this forms your overall PCI DSS scope. So just for a better clarity, let's look at this process within reference architecture. So here we have a 3-tier web app architecture, which is receiving cardholder data, storing cardholder data, and sending it out to a payment processor, a simple architecture. So as we see, the first thing we need to do is identify the CDE system. So to do that, we need to identify the cardholder data flow. So here we see cardholder data is coming from an end user through some network devices, received by the web application, processed by the application tier, and stored by the database tier. So if we go back to the flow, the second step is to identify the AWS services that constitute this flow. So here we see we have an application load balancer, EC2 instances acting as web instances or an application instance, and we have some RDS instance that is storing the credit card data. Once those services are identified, we need to identify what type of those services are. Are they infrastructure service, are they containerized, or are they abstracted services? Once all this is done, we have our core, which is your CDE. Now, moving out from the core, we have to identify our ancillary services. Again, this would be, as per the guidance, they're connected to our security impacting systems. So coming back to the reference architecture, you're connected to systems, can be other EC2 instances, such as a Bastion host that you are using to communicate with all your instances. The security impacting systems can be your AWS web application firewall that is used to provide protection to your web application. This can be like a logging bucket, which is storing the application or the infrastructure logs. So all this forms your ancillary services, and when combined together, this is your final DSS scope. So this is where you know what you need to protect. So once we have defined our scope, the next thing for us is to define our segmentation boundaries to make sure that anything that we have identified out of scope remains out of scope. And next, we'll see how to define segmentation boundaries on AWS, and my colleague Aditya will walk you through those steps.
Thanks, Avik. Just a show of hands, can you guys hear me all right? Perfect, thank you. So, hi everyone, my name is Aditya Patel. I'm a security architect with AWS Professional Services. I help our customers migrate their most sensitive workloads to AWS with confidence. So far we have seen segmentation, so far we have seen the scoping on AWS for PCI workloads. Now let's look into segmentation. Segmentation lets you build controls to isolate your in-scope resources from out-of-scope resources. In AWS, that can be done at 3 levels or 3 layers: at the account layer, at the network layer, and at the application layer. Let's start with the account layer. Let's first see what AWS account means. So AWS account is what encapsulates all of your resources in AWS. It provides ways to access those resources either via the console, the web UI, or via command line, or via SDKs. It provides the highest level of segmentation that is available in AWS. And by design, all the resources, they are logically isolated from other AWS accounts. And it's by design isolation. What that means is that when you use AWS account layer segmentation, you do not have to worry about validation on your own. That account level isolation provides sufficient isolation, and AWS has gone through that assessment, and AWS meets that level 1 requirements for PCI DSS. Now, as a best practice, we recommend that you use multiple accounts, put your PCI DSS workloads in one account, and use other systems in another accounts. What that leads to in practice is you end up having more than one account. And we have a service called AWS Organizations to help with that, to manage multiple accounts. This is how it looks like via a reference architecture. So in this case, we have our CDE systems. It's a similar architecture. If you look inside that box, small text, we have our load balancer, we have our web application processing the card data, and then the application server and a database server using RDS. Then we have our other systems here that form shared services or connected to systems or security impacting systems. And then we have our out-of-scope accounts. So the in-scope items would be the bottom line here. And we have segregated our out-of-scope system separately. Now this means that managing these accounts could be a hassle. So we have a service, AWS Organizations, as I mentioned earlier, that lets you manage that. So how you can do that is you would create another AWS account called as Organizations Master Account. And that will allow you to manage these accounts and allow you to add additional controls. There are various constructs available in AWS Organizations, such as the OU or organizational unit, which lets you group your accounts. So we have a core OU with all the connected systems here. We have a PCI OU with all the PCI or CDE systems. And then we have a non-PCI OU. Organizations also lets you add controls such as SCPs or service control policies that allow you to add access control policies on a higher level. You can also consolidate your billing in the organization's master account to get things like volume discount. Next up, let's look at the network layer. Now, sometimes it's not practical to have your all PCI resources, PCI DSS resources in one account. What if you need to have one account, and within that account you have more than one kind of resources? So for that, we use network layer segmentation. At this layer, we recommend that you use something called security groups that we have in AWS. The security groups, think of those as your virtual stateful firewalls. So you can have these security groups attached to your EC2 instances or your infrastructure services and add those respective rules to control your ingress and outgress or ingress and egress traffic from those instances. Something to note here that by default, having these security groups does not make you meet the PCI DSS requirement because they have an open outbound connection. So you need to keep that in mind and add the right ingress and outgress rules so that an in-scope system is communicating with the right outbound system. Additionally, you can have third-party host-based network firewalls in AWS that you can leverage. And here the lowest segmentation boundary is an ENI or Elastic Network Interface. This is how it looks via reference architecture. So we have two accounts here, the CDE account and the connected to systems. We have two availability zones for reliability, and the orange boxes represent the EC2 instances. Now, what if the EC2 instances need to communicate from the CDE system to the connected to system or vice versa? We can do that easily with security groups. Now, security groups add a sufficient layer of segmentation. We can also have another security group here for out-of-scope systems. Just for reference, we have the in-scope security group systems and then out-of-scope. Next up is the application layer. Now, Avik talked about the abstracted or containerized services. Those services operate at a different layer. They operate at the layer 7 or application layer. In AWS, everything is an API call. So no matter what service you are using, in the underlying architecture, it uses an API call. For these services, network isolation is achieved by design. So that's AWS responsibility of the shared responsibility model. For scoping of these services, and these services include RDS, which is the relational database service, or Amazon Fargate, AWS Fargate, that is for the containers, or DynamoDB. So scoping for these services is data-driven. So what that means is if two API endpoints, if they're exchanging any CHD or cardholder data, that means that the other system or the other endpoint would be in scope. And segmentation is application-driven for these services, which means that application logic should define how the segmentation boundary exists. Let's look at this via an example. So we have an abstracted service, Lambda, which is our serverless function service, and that is communicating with two endpoints, Amazon SQS and Amazon DynamoDB. With one of the services, it shares the exchanges the CHD, with other it doesn't. So with DynamoDB, it is exchanging the cardholder data. It means DynamoDB is in scope. With Amazon SQS, there's no CHD involved, that is out of scope. So that is the scoping part, using the data. For the segmentation, that needs to be done by the application logic inside the function that is in Lambda. Now, with these concepts in place, we've seen how scoping works and how segmentation should look like. We also have some edge cases that we should consider. Let's start with hybrid environments. We often see customers using hybrid environments where they have their on-prem data center and also their AWS cloud environments. And for PCI workloads, sometimes we see use cases where they have the PCI systems in both of these environments. So the takeaway from this is you can have these two systems, and we need to then take care of how they're communicating. So CDE systems can communicate with other CDE systems from cloud to the on-prem. The connected to systems can communicate as well, but the out-of-scope systems in either should not be communicating with each other. In that case, the out-of-scope systems would also become part of the scope. And as a best practice, we recommend two things. One, try to design your systems in such a way that your PCI DSS resources are in one of the two. And if you have to use such an architecture, then use defense in depth, multiple layers of segmentation boundaries. Next up is the custom application APIs use case. So we have seen how application, the API level at the for AWS services work. But what about custom APIs that you develop? How does segmentation work for those? So say you have a custom app and you develop custom APIs that are communicating with AWS. For that, we recommend something called as Amazon API Gateway. Think of it as like a jump host. So API Gateway acts as the segmentation boundary there. And it provides additional capabilities such as attaching web application firewalls or enabling microservice-based architectures. This is how it looks. So on the one side, you have your customer data center where you have your custom applications and APIs. On the other side, you have your in-scope systems. An API gateway, the purple box there, is sitting in between, segregating these two environments. Despite using Amazon API Gateway, you still need to keep in mind that no CHD is flowing from any of the endpoints, and you need to validate for that. Last edge case that we have here is of microservices. Now, containers and microservices are gaining a lot of traction because of the flexibility and agility that they provide. In practice, you can have thousands of containers running in your environment. So how does segmentation look for those? At Amazon, we have multiple container services. Let's look at one of those. So Amazon ECS, or Elastic Container Service, it lets you run your Docker containers in AWS. It provides two launch types or two ways to deploy your containers. One is the Amazon EC2 launch type, and another one is the AWS Fargate launch type. With Fargate, you don't have to manage your underlying clusters and servers. With Amazon EC2, you can customize those as well. With EC2 instance type, since you have more than one container running in practice, you can group them into clusters. With Fargate, you can group them into a construct called as tasks. And there's a configuration file called task definition that lets you manage all this. So for the segmentation, you would use security groups at this cluster or task level. We provide that capability that would provide the isolation. So we have seen how segmentation validation, how segmentation works on AWS. Now let's look at validating this segmentation. So PCI DSS requirement 11.3.4 requires that these segmentation controls be validated through periodic penetration testing. It also provides additional guidance that each of these segmentation boundaries, if you have applied defense in depth, be individually tested. So for different layers, this is how it looks like. For the AWS account layer, as it is by design isolation, there's the client responsibility. You don't have to perform any validation. It is validated as part of the AWS PCI DSS Level 1 assessment. For the second layer, AWS network layer, which is the software-defined networking using your VPCs, you need to validate the security groups through network penetration testing. You need to ensure that if you have two instances running and if you have security groups attached to them, that you cannot ping from one instance to another. For the third layer, that is the AWS API or the abstracted services layer, as we saw, the scoping is data-driven, but the segmentation is application logic-driven. So you need to validate and test your segmentation. So you need to perform testing on the application logic. For the custom API or non-PCI validated services, you need to do both. So you need to perform network penetration testing and application logic testing as well. And last point that we have here on the validation is that penetration testing on AWS, we make it possible to easily perform pen tests on AWS. Until some time back, you had to require explicit approval from AWS Security to conduct penetration testing. That has changed some time back. Now there is a list of certified services that you can perform the penetration testing without the prior approval. Check our documentation for that. We recommend following the AWS acceptable use policy. And also another recommendation is that the third-party vendors that you are using, please carefully vet them and make them undergo your own organizational assessments before onboarding them. With this, let me invite back Avik to wrap it up.
Thank you, Aditya. So till now, we saw how we define our scope, how we can define our segmentation boundaries on AWS, and how we validate those boundaries. So these are as per the PCI DSS requirements or guidance that is out there. But being a good security steward, we must design our compliance such that compliance is achieved through security and not the other way around. So we have to go above and beyond what PCI DSS requirements are, which are the basic requirements, and we have to make sure that our environment adheres to security best practices. So to do so, we'll look at the NIST Cybersecurity framework, which defines 5 functions to define a lifecycle management of your cybersecurity controls. So in this case, your PCI DSS scope and segmentation controls. So first function in the framework is to identify. As part of identification, we identify our scope and the segmentation boundary that needs to be there to protect our scope. Next in the cycle is protect stage, where we are protecting our scope boundaries by defining segmentation controls. So on the base of where we are defining segmentation control at the account layer, network layer, or the application layer, we define those at this part. Next is your detect stage. In this stage, we have to have controls to detect any changes to this scoping or the segmentation boundaries. So we should not rely on one-time scope assessment or scope validation and wait for it till the day before your assessment, and you get a call in the midnight that something has changed, and whatever your scope was maybe is actually not it is. So to avoid that, you need to have detective controls to make sure that anytime your scoping or segmentation boundary changes, you are made aware of that. After detection is the response stage, where you are responding to the alert that you get to make sure that you respond back in a manner that is applicable. And the aim of response step should be to recover from those changes. So if there were some unauthorized changes, you change back those controls to whatever there was before. So with this definition of controls, with this framework that you have in place, you would be rest assured that the segmentation boundaries that if you define are always what you intend it to be. On AWS, this can be achieved with the AWS tools and features. And if you look at AWS Cloud Adoption Framework, it defines a security perspective where it defines 4 pillars, where it's directive, preventive, detective, and responsive. In directive, for PCI DSS, the PCI DSS program and the guidance is your directive control, which dictates how you should direct your controls to be. As part of preventive, AWS provides multiple services like CloudWatch events, AWS Config, you have a CloudTrail that can be used to detect any changes to your segmentation boundaries or to your scope. After that is detected, comes the responsive framework, where you need to respond back, and most probably you will try to do auto remediation through Lambda functions so that you change back the state of those segmentation control to initially that was the intention of those controls. So through this exercise, we see that there are you have to define proactive security controls first to make sure there are no changes, and then you need to have detective controls in place. So if anything changes, you are notified that. And once notified, most of the control, your aim would be to do an auto remediation so that no manual intervention is required and those controls are changed back to their initial state. So with this, we talked about many different concepts throughout this session, and I'll try to put it back together in a single slide, so for your reference. So firstly, we went through how we define our scope. We looked at that we should start with our cardholder data flow and try to identify the types of AWS services in flow, try to identify the ancillary systems in the flow, and this gives you the CDE or the full scope of your DSS assessment. Once the scope is identified, we need to identify our segmentation controls. And on AWS, as Aditya showed, that this can be at different layers. First is try to group similar security requirements or similar scope resources into similar AWS accounts. Now going further down, if you need communication in between resources in accounts, you define security groups as the segmentation boundaries at your ENI level. And if you have abstracted services in your scope, you have to define application code as a segmentation boundary to ensure that non-credit card data is not flowing where it is not intended to be. So with this in place, you will have a robust framework where you can define your scope, define your segmentation boundaries, and most importantly, you can talk to your QSA during your annual assessment and validate that whatever you have defined your scope is actually what the scope should be, because this is as per the PCI DSS guidance and AWS best practices. So with this, just few links for further reading. There is an AWS white paper on scoping and segmentation on PCI, which talks in details about whatever we went through. There is a quick start. If you're familiar with quick starts, those are like auto-defined cohort formation templates that defines a PCI DSS, not compliant, but a meeting framework for you. And you have the AWS security best practices, and I would also recommend read at the AWS shared responsibility model if you haven't done so. So with this, thank you all for coming to the sessions. And no, I was just saying if you have any questions, we'll be here for next 15-20 minutes, so feel free to come up. Thank you.